Alright, we just understood that even refractive index can be found by the real depth by apparent depth, and let's see how to use this into this problem. I drew this two diagrams, it takes a lot of time. I hope you understand this. Now let's go ahead and talk about the problem and see how it connects to the diagram which I've done. But in fact, when you have the problem given to you, you should be able to draw the diagram yourself. But anyway, we'll discuss this and how it works. A transparent glass cube. Okay, this guy is a cube. I've drawn a three-dimensional image here so that you can understand better. All right, and there's a three-dimensional image which I can see that there are 6 faces, a box kind of thing. All right, a transparent glass cube of size 0.2 meters is this length of one of the sides is 0.2 meters, contains a small air bubble. This is what I'm exactly talking about. Okay, now if I see it from this phase, I can see that this bubble appears to be a little nearer to me. All right, and the apparent depth is given as 0.05 centimeters here, meters in fact. And if I see it from the other end, from this end, I can see the same bubble to be appearing 0.05 meters from this end. All right, and that's how the problem all about. When viewed from directly from the nearest end, it appears to be so much from the face, and when viewed from the opposite face, that is this face, it appears to be 0.075 meters. Now I hope you understand the problem. All right, calculate the actual distance of the bubble from the nearest face. It means, let's say the bubble is exactly here, but I can see only here. So what is the exact length? I'll call it as x, which I don't know. I need to find out this guy. All right, but when I see it from here, I just see 0.5 meters. All right, 0.05 meters in fact. All right, now that's what it is. Now I don't know this guy. This is the real depth and this is the apparent depth when I see it from this end. All right, when I see it from this end, the real depth would be 0.2 minus x. Why? Because the whole thing is 0.2, and if I remove x from this has to be 0.2 minus x, and that's my real depth, and this is the apparent depth. Okay, I use the same formula from this side and that side and see what happens. Okay, now let's talk about the nearest side, this side. Then refractive index is given as apparent depth or real depth by apparent depth, and I can see that real depth here would be x, the real depth, which I don't know, so that is x, and what is the apparent depth would be 0.05, so I'll just write 0.05, and that is the refractive index of what? It is the refractive index of the medium, that is this box. All right, now let me see it from this end. Okay, that's my first equation. Again, I'm writing refractive index in the same box, but I'm seeing it from this end. Then what is the real depth? The real depth is this length, that is 0.2 minus x. So I write 0.2 minus x divided by, and what is apparent, where is exactly it is visible is 0.075 meters, that is 0.075 meters. Now that's all it is. In both the cases, I have the refractive index of the same guy. Can I say that these two guys are same? Exactly, because it is nothing but the refractive index, the same cube. So if these two are same, these two should also be same. I'll just equate equation 1 and 2. Equating equation 1 and 2. Why am I doing this? Simply because this is the refractive index of the same box, and this is also the refractive index of the same box. So it means the right hand side should be same. So if I equate that, I can get x by 0.05 should be equal to 0.2 minus x divided by 0.075. Solve this guy, we'll see how it works. I can see that if I cross multiply this, I'll get x into 0.075 is equal to 0.05 into 2, that is 0.2 minus x. Okay, if I open this guy, it should be like, let me multiply both the sides by 100 now, or 1000 best, so that I can remove this. It becomes x into 0.075 into 1000. It's a good deal to multiply like that, so that I don't have any decimals to solve. 0.2 minus x. Okay, and what happens here? All the 3 decimals are gone, so I'll get x into 75. All right, into 75, and here I can see that out of these two zeros, this is gone. I'll get 10 into 5 into 0.2 minus x. Okay, keep this bracket aside. This is 75x is equal to 10 into 5 is 50 into 0.2 minus x. That is 75x is equal to 50 2, again I can cancel this 1 0, that is 10. All right, minus x. This is what I had, 10 minus 50x. If I multiply this also, what do you get here? 75 minus 50x, or let me take it outside, 75x plus 50x is equal to 10. I get something like 75 plus 50 is 125. X is equal to 10, and x is actually equal to 10 by 125. Solving for the value of x from this expression, I get x as 10 divided by 125. If you solve this with calculator, it would be around 0.08. Now that is part of equation. It was calculate the actual distance of the bubble from the nearest face, that is the value of x. I got it like that. And again, I have to calculate the refractive index. From the first equation, we calculated refractive index given as what? It was the real depth divided by 0.05, that is apparent depth, right? That is simple, real depth by apparent depth. Real depth supposed to be x, and apparent depth was this from this end, right? Now refractive index of the medium can be given as x, supposed to be 0.08 divided by 0.05. That comes up to 8 by 5, that is 1.6. So that ends the problem here. It's a very important problem, and most of the times asked problem in the exams, and it is also 5 marks. So don't miss this. Do a couple of more problems the same, and what only can change is the numbers or the numericals here. All right, the whole procedure is same. If you can understand this problem, you can do any similar type problem. I hope you understand this.